Ciao friends! In this video we will see how to customize a date table in order to manage periods that don't correspond to a specific group of months or weeks. For example, we will consider the term in a school calendar, but the same approach could be used for seasons or for any other kind of custom period you want to apply to the date table. We will see how to manage comparison between different periods so that you will enable the user to create reports that compare the content of the data corresponding to different periods of dates without any particular effort but with simple DAX formulas. Let's start with the demo. Let's see the demo files we prepared for this example. We have the classic Contoso database. So we have the information about sales that we project by year, by month, and so on. But of course, we don't want to use the standard calendar. We want to use the school calendars and the terms we have in the school calendar, because we want to analyze, in this case, the sales. Of course, you probably want to use the student grades in a real example for the school, but the idea is that we don't want to introduce new data, and also we have more data to analyze in Contoso, and the problem we want to identify is valid for any custom period that you might want to define. And where do we define this period? We define these periods in a table called terms, which is the table that we see here. And this table has the list of dates of date ranges that we have for each term. The goal we have is we want to display these two columns in the date table, and we want to use the year and the school year and the term to group data, to group all the days that are within this date range. And we want to use this information in our analysis. So this is the goal. And basically, we have just to translate this information, but we also want to create measures to compare the value for one term with the value of the previous term or the previous term in the previous year that could be in a completely different range of dates. This is the same thing that could happen in any kind of definition of a custom period, like the seasons or maybe particular periods for the kind of activity that the company has. And you want to compare apple with apple. So let's see what we can do. So the goal, as I said, is to move these two columns into the date table. But before doing that, it's useful to add an information to this table, because this table at the moment has three different terms for each year. You see that, for example, for this year, for this school year, 2017-2018, we have autumn, spring, and summer that are defined in this range of dates. As you notice, there are dates that don't correspond to any term, and we also have this column term number that is used to define the sort order of the term name. So what we want to see is autumn, spring, and summer in this exact order, regardless of the names that could be different also in different languages. However, it's useful to start defining a sort of unique identifier with a sequential number for each term, because this information will be very useful for different reasons. First of all, we have a unique identifier for each term that can be useful later when we want to also create a relationship. But more important at the moment is that this number will be used to make it easier to compare different periods without introducing a logic that has to look at the year, the local number for the term number, and so on. So we want to create a column in this table that will be useful later, that we call term sequential number. So term sequential number. Now we could use a simple rank for the term based on from date or to date, but actually it is a better idea to use an algorithm that produces always the same number, even though we move the same logic into another model, or over time we change the population of this table. So something that depends on the year number, for example, could be useful. So let's extract, for example, the first part of the year. So if I look at this year, I get that the initial part, so the starting year of the entire school year. And then I use an incremental number where every year has, in this case, 3 periods. Of course, this formula could change if I have 4 or 5 or 6 periods, but the idea is that if I get this number using left, so this is a string, so I can get the first 4 letters of the year column, and I know that this is a number, so I multiply this by 3, y by 3, because in this case I have 3 periods, 3 terms in each year. If I had 4 seasons, I would have wrote 4 now, and then I sum the term number, which is the local number that we use. This starts from 1, and this is the local number for each term in each year. What I get at the end is a sequential number. So if I click enter, you see that I have a sequential number that uniquely identify the year. So this column will still be a hidden column, so I don't want to show this column in the report, but I want to use the information I have in this table to extend my date table. And how can I do that? Well, for each row of the date table, I can compute the value of calculated columns. And the first calculated column I want to create is, for example, the column that contains the term, the name of the term. So let's write term, which is equal to what? I have to retrieve the name of the term from the table that has the configuration. So how do I filter the table terms? Well, I can just use a simple filter terms where the from date is less than or equal to date, so the current date for the column. And I have now 2 nested row contexts. Usually this is not a good practice, but for a calculated column on a relatively small table, it's something that is easier to write, I would say. And I also added that the toDate in the terms table must be greater than or equal to date. Now I'm assuming that the date is inclusive for both the from and the to. Pay attention in case you have to use less than or greater than instead of less than or equal to or greater than or equal to. But for the definition we made, this is fine. And now the filter table I wrote this way, assuming that we don't have overlapping periods, should return only 1 row. But we need only 1 column, so the easiest way to retrieve only 1 column from a table that I know should have only 1 row is to use select columns. Now I could write here terms term, and this should work despite the warning we see. But let's say that we don't like this error. This is perfectly valid code. It's just not accepted because of a bug of the current version of Power BI Desktop. So we just write term and then comma, and this way we avoid the warning, the error that is not an error in the DAX editor. Now we have the term name in this column. And of course, if we take a look at the values we have, we see that we also have a few blanks because there are dates that don't correspond to any school term. We just can repeat the same calculation for the year. But of course, we already have a column year, so we create a column. I just copy and paste the code. This will be the term year, and what I get is just the year value from terms term year, for example. Let's use term year just to have the same, even though this parameter, I mean, it would be not necessary, but let's move forward. So we have the term year, we have the term, and we also want to include actually, this is the column that we want to display, but because we want to keep the sort order for the term column, we also want to include the column term order. So let me create a copy and paste again, term order and term number. Let's use the same definition, term number, because this way I will use a sort column by term number. And of course, I will hide the term number column. And at this point, I still have to include the column, the calculated column I added before in my term table, because in my terms table, because the sequential number I created is actually the key to create simple DAX code in my measure when I want to compare two periods. So let's repeat again a number of copy and paste. We will see later that we could reduce this cut and paste by creating a relationship, but I will do this later. So here I create term sequential number, where I use term sequential number here and here, and I click OK. And just for the sake of, it doesn't matter which name you put here, because as you see, the name of the column that we can see here is defined by the name of the column, the calculated column that we defined at the beginning. So actually, the name that we include inside the columns really doesn't matter. Also, the term sequential number is a column that I want to hide. So hide in report view, and so I make sure that this column is not visible. Now, we could move forward now, but before doing, before completing the report and creating the measures, there is one important consideration. What happens if the terms table has overlapping ranges? We intentionally used this technique, select columns filter, in order to get an error in case there is more than one term that could include the same date. For example, imagine that there are two ranges that include the same date, April 1st. At that point, the select columns would include only one column, but the filter returns two rows, and these two rows raise an error for the evaluation of the calculated column. This will stop the refresh of the model, which is good because we don't want to get a report with wrong data. However, the error will say, oh, we have two rows and the number cannot be converted, the two rows, a table with two rows cannot be converted into a number, something like that, which could be hard to understand for the system administrator, because when the refresh fails, once you publish the report, the error is sent to the system administrator in the log of the refresh or in a message sent to the administrator. And we want to make it easier to understand what is happening. We can predict if something happens here, we may want to display a different error message. So one technique we could use is we could wrap the entire calculation into an if error. So if we detect an error in this evaluation, we write a specific error message. For example, error check overlapping dates in a terms table. It's just an example. You might want to write something different. But the idea is that this way, if there is an error in the configuration table, the error will be displayed in a clear way in the log of the errors for the refresh. Or in case this will generate a data type error in the definition of the calculated column, the technique is to sum 0 if this is a number, or append an empty string if this is a string as a column. But in this case, we don't have the problem, so we can move forward this way. This is just a technique that sometimes is not well known, but is actually very effective to customize the error message when a refresh fails. Now, let's go back to the report. Now we have the entire infrastructure in place, and we want to, first of all, we want to see if we can see the data using our new columns in the date table. So we can get rid of the column here that we have at this moment in the rows. So we remove this, and we add the date, I would say term year, followed by term name. So I also add the date, term name this way. So you immediately notice that we have all those dates that don't belong to any term are displayed with a blank term year. And let's say that if we want to not display this line, we can simply add a filter that, for example, for term year, I could say select all and remove blank. So this way we only have our the term years where we have some data. And we can read down and see the values by term name. At this point, you could also add months and days and so other columns of the date table, but this is not our goal. The goal is that now we want to create a measure to compare the current term with the previous term. In order to do that, I have to create a measure. So let's start to create a measure that we want to include in this report that I would call previous term. It should be sales previous term, but I want to reduce the length of the string just for the demo. So the previous term is what? Let's start with the simple sales. So let's repeat sales amount at the moment, just to put this in the report and see the value side by side. What we want to do, so let's see if I can draw this. We want to move this number, instead of writing the number here, we want to write this number here. So it should be displayed here. So the value of autumn 2017-2018 should be the previous term, which is summer in the previous year. And of course, this is easier when you are within the same year, because spring should be autumn and so on. And once you have the previous value, you can easily compare one term with the previous one. Then we want to do the same, but we want to do a similar comparison, getting the same period in the previous year. So for example, if I want to compare the previous year, I want to write this value in a new column that I will put here, that I will call same term previous year. Same term previous year is probably what defines better what I want to do. But let's start with the previous term, because you will see that the two measures are very similar. So how can I write this calculation? Well, you know that we basically we want to calculate the sales amount where what is the column that we can use to apply the filter we want. It's the column that we created. You remember we created a column with the sequential number, term sequential number, if I remember well. So let's see if I have in date term sequential number. This is the column I want to filter. And I want to filter this column going back 1. So I need to write, let's say I will use a variable to do that. So I want to create a variable previous term, where previous term is the current value of term sequential number minus 1. So this is the goal. So I need a variable. So let's create this variable, which will be the current term minus 1. But of course, I need the current term. So I create the variable current term, which is, how can I get the current term? Selected value. So I use selected value for the same column, term sequential number from the date table, because we are showing the date table in the report. And I think that we can return this value here. Now, I think that this is not enough, because if I use this technique, I change the term sequential number without changing any other existing filter in the filter context. So because we're not filtering the date table, which is what happens when you use the time intelligence function, and that operation removes the filter context from the date table, we add the remove filter state manually, because we are not applying a filter over the date column of the date table. And if I do this, I can obtain this kind of visualization, where actually I have the right visualization. Some refinement, it could be that I don't really want to see the value of the previous term for a term that doesn't have any value, so we probably are beyond the last available information we have in the model. So we can write some a conditional statement, let's say, that will not display the value if the comparison doesn't make sense. How can I do that? Well, I could use, I could check whether the selected value is blank or not. So if I actually have, if that term exists, and basically I can use a notice blank for the current term, because otherwise, I mean, it would be blank minus 1, it filters minus 1. In any case, it will not find anything but why to execute the calculate if I don't have any value. And I also want to check that the previous term is greater than 0, because again, if we get the value that is 0, current term is blank or 0, -1 will go at a negative number, and if we get a negative number, certainly we don't have anything to display. So rather than displaying a number, I prefer to display blank. Maybe that is not actually necessary, and actually this doesn't solve the problem for the summer here, but okay, that's something that we could solve in other ways. For example, taking a look at the last date available, or in this case we could reduce the date table, because if you don't use the standard time intelligence function in DAX, you can afford having a date table that doesn't have actually all the terms. So okay, that's not what I want to go deeper for the evaluation, because actually the important element here is to understand that in order to evaluate the previous term, I base my business logic on the column term sequential number that is a sequential number regardless of the year that we defined. Now, let me copy this, because the next measure I want to create is a measure that will be the same term in the previous year. And it's the same thing, it's the same code, the only difference is this number. So if I know that every year I have 3 terms, I can just go back 3. And once I create this value, I create this measure, I can include the measure in the report. I want just to set the format in a better way. And you see that now I have exactly what I wanted. So I have the number of summer that is displayed in summer for the following year here. And this is exactly what I wanted to do in my report. So once I have these 2 numbers, I can do a difference, I can do a percentage, and so on. But the idea is that I try to keep the code very simple, and the business logic doesn't have any conditional statement based on, oh, I'm in term 1, so I have to go term 3 of the previous year. That would be a big waste of time executing the measure. So this way we obtained the desired result. But there could be another thing to consider. If you look at the measure I defined, I removed the filter from date, which is the right thing to do, because I actually want to remove the filter from the year and from the term, because actually I want, going back 1 term, I could change the year. So by filtering the term sequential number, I obtain exactly what I want. But what if let's copy this example, what if I have a slicer where I select only working days? Now, if we look at what is happening now, the value for sales amount, the value for sales amount, for example, in the cell, is considering the filter applied by day of week. But the value in previous term and in same term previous year is ignoring the slicer, because we wrote remove filters, and remove filters remove every filter. So if you want to keep the ability for the user to use columns that create a filter across the term, for example, the working days that you have, something that is present in any term, in any set of dates, so not something like, for example, the month name, that of course that will be more difficult, because if you change the term, you might want to change the month name, but for example, you might not want to remove the filter from working days, from day of the week, from holiday, for example. So at that point, we have to change the code that we wrote, replacing remove filters with an all except. By writing all except, we obtain exactly the same result. We remove the filter from the date table, but we can specify we want to keep if a filter exists, keep that filter on the columns that I specify now. For example, day of week that I had now. Day of week is something I want to keep. But I could also keep the day of week number, the day of week short, which is a shorter version of the name, and maybe the working day, which is another flag I may want to use, to filter only the working days or non-working days. So it's a little bit longer, but it's always the same code. So I can copy this code and I can paste this code in same term previous year, and I obtain exactly the number, the numbers that I want to see, which are those numbers that consider the slicer day of week that you see in this area. So this slicer day of week has been considered now in both sales amount, previous term, and same term previous year. So actually we have the values that we want. We probably completed this way the analysis and the definition of the measures and the approach that we have to use. There is only one possible further optimization, or let's say different approach, which is the following. If we take a look at the calculated table that we, at the calculated columns that we added to the date table, we basically added the number of columns to the date table, which probably is also what is easier for the user, because actually we only make the date table visible to the user. When we go in the report, we don't see the term table. So if I zoom this a little, if I zoom this a little bit so that we don't lose the video, you see that the terms table is not visible here, and the terms table has been included in the date table. But if you don't want to use this approach and you want to show the terms table to the user, because you prefer to keep that as a separate entity, then at that point we could use a slightly different strategy, which is the following. Let me show you. So if I have the term sequential number defined in date and in terms, you remember that when we defined this column in terms, we said this is a unique identifier for each row for the terms table. Now we can create a many-to-one relationship between the term sequential number and the term sequential number. We have one row in the terms table, many rows in the date table. And of course, if we have a blank term sequential number in the date table, it will be displayed with a blank term also in terms. So exactly what we have now. We can get rid, if we use this approach, we can get rid of these columns. So we can just remove all the columns but term sequential number, and we create the connection and we show the columns in terms. So let me change the visibility. So we want to show the term and the year, I would say, yes, the year and the term only. So we only want to show these two columns, year and term. And then we want to create the relationship. Actually, I can already create the relationship. And then I remove the columns that I don't need in the date table. So I can remove the term column, the term number column, and the term year column. Of course, I have to make sure that I use the sort by column in the terms table for term and term number. Now you see that I only have now the term sequential number is the only calculated column I kept from the columns that I created before. And I make sure the term has a sort by column. I have to go in the date table, in terms, term, and term is sorted by term number. Perfect. So it's already set. I didn't remember if I already included it. And then I can go back to my model. Of course, now it's broken because all the references to the column that I eliminated have to be removed. So let's go back to this version. And now we no longer have anything here. So we can use the terms year in the rows, and then the term in the always in the rows by using this to drill down. We can apply the filter over term year that has to be not blank. So I apply this filter, and then I take a look at these measures, because in reality there is something that I prefer to do at this point. So there is, so let's go to, this is the same example by using also a remove filter. That will not change, because by using all except date, we are actually removing the filter from both date and terms, because now that we created the relationship, the terms table is part of the expanded table date, and so when I remove the filter from date, I also remove the filter from the terms table. The only thing that you might want to do is instead of using date term sequential number, I have a preference for the column that is exposed. So we always try to filter the column on the one side, not the column on the many side. In this particular example, as you have seen, the numbers will still work, but it's a best practice to when you have a relationship involved, you always filter the column on the one side, not the column on the many side. So if I go to term sequential number, I use this column here and in the filter. I do the same also in same term previous year. It's not strictly necessary, but I prefer, it's more clear that I'm actually using the terms table as a way to filter, and this is usually a best practice because it makes the code easier to understand if someone take a look at the code later. But as you see, this approach is similar. One thing that you have to pay attention when you create what we call a calculated relationship, so a relationship based on a calculated column, is that in the calculated column, so let's go back to the date calculated column term sequential number. In this expression, we want to stay away from calculate and any other function that could generate a circular dependency. If we use calculate here, we would have had a minimum advantage in performance, and we are in a calculated column where we actually don't need a particular performance. But the complexity of managing the circular dependency is very high. So in order to avoid to have to write actually longer code to manage the circular dependency, and to avoid that, by using this approach that doesn't use context transition, doesn't use implicit filter, doesn't use values, all those functions that could generate a circular dependency when you have a calculated column for a relationship, we make sure that the code works without any issue. So we have seen that we can solve the problem of generating a date table that is customized with a specific term for the school calendar. And of course, the example with Cantoso is probably not the best one if we consider the school, but the same problem could be faced when you have, for example, seasons or any other kind of custom periods that you might have in a business, and you want to compare consecutive periods or same period in different years, but we have this definition of custom period that you want to manage. Don't write complex Xcode in your measure, move the complexity in columns that you have in the date table, and keep the code simple in DAX for your measures. Enjoy DAX!